Hi, today's topic is DDMS features part 1 presented by Karthika Raghupati. In the last session, we have discussed about what is DDMS. DDMS is a Dalvik debug monitor server. We have discussed about how does it work, how does DDMS interact with the debugger, and what are the ways of launching the DDMS. That is, one is through the Eclipse and other one is through the command prompt. We have a small introduction on the features of DDMS in the last session. Today we are discussing about DDMS features more briefly. The agenda of today is we are discussing about how do we view heap usage for a process, how do we track memory allocation of objects, working with an emulator or device file system, and examining the threats information. Let's launch the DDMS now. So as I told you, I launch my DDMS through the command prompt. This is one way of launching. And I'll copy the SDK tools path, which I have to give. Okay, I see that DDMS is launched now. Now let's launch the emulator. So in the DDMS, I see the emulator 555 is getting launched. It will start launching all the applications. Wait for a few minutes. So here I see all the applications are getting launched. Settings, phone, contacts, launcher, email, clock, media, exchange. MMS, settings. Okay. Now the emulator is launched. All the applications are also launched. So here if I click on any process, in the information, I could see the app description of that process, the version of that process, the process ID, and the supporting the profiling control and all. So the first one is viewing heap usage for the process. So this feature will allow us to view how much heap memory a process is using. This information is useful in tracking heap usage at a certain point of time during the execution of your application. So I'll select Android.phone. Here I have an option, show heap updates. Click on that. This is the option for viewing the heap information. Click on that. For this process, you could see the heap button here. In the device tab, you have an option VM heap. Click on that. So here, there is a button called cause GC. GC is the garbage collection. This will enable the collection of heap data. When the operation completes, you can see a group of object types and the memory that had been allocated for each type. Now let's click on this cause GC. Okay, you could see the heap data. So for this process, which we selected for this, we could see the heap size of that process, how much memory is allocated, how much free space is remaining still, and in percentage how much it is used, and the objects. So these are the object types. In this list, we have the objects. If we click on any object type in the list, you can see the bar graph. This bar graph will show how much number of objects allocated for a particular memory size in bytes. So I'll click on any object type. I could see how much memory is allocated. So here you could see the number of objects allocated for a particular memory. Again, if I click on this cause GC, this will refresh the data and fetch the new data again. Will update how many times you click it, you will keep on fetching the new data. This is about the heap usage, and the next one is tracking memory allocation of objects. So if you want to, before that, if you want to disable this heap usage, if you again click on this show heap updates, it will disable your heap data. And the next one is tracking memory allocation of objects. Select which you want to see the allocation of objects. So I'll select the calendar, suppose. So this feature is helpful for us to track objects that are being allocated to memory and to see which classes and threads are allocating the objects. This will allow us to track in real time where the objects are being allocated when you perform certain actions in the application. This information is valuable for accessing memory usage that can affect application performance. So for testing the application performance, you can use this memory allocation of objects. So you have an option, allocation tracker, in the device tab. So if you click on this start tracking, this will begin to allocate all the trackings. At this point, anything we do in the application will be tracked. So I'll click on start tracking. And now I'll perform some actions in my emulator. So I'll click on this get allocation. When we click on this get allocations, you can see all the list of objects that have been allocated since you clicked on the start tracking. So this get allocation will show you all the list of objects that have been allocated. If you click on any specific row from this list, you could see the detailed information. So I'll click on anything. So here you could see the detailed information such as the method and the line number of the code that has been allocated for that object. So you could see every information for that. If you click on this stop tracking now, it will clear the data and stop all your trackings. This is how you view how much memory is allocated. And the next one is working with an emulator or device file system. Here in the device you have an option, File Explorer. Click on that. In the File Explorer you have two options. One is pull file from the device and other one is push file onto the device. So this will allow you to view, copy and delete files on the device. So this feature is useful in examining files that can be created by your application, or if you want to transfer files from the device or to the device. So suppose I want to copy this file to my device. I have to select where I want to copy. Okay. We'll copy all the folder to your desktop now. If you go here, you could see the cache. Could see the information in this. We'll give all the information. The folder is stored on the desktop. The same way, now we want to push the data from the device. So click on this. Select the folder, okay, where you want to copy this. Now click on this. Okay, I'll select some txt file. Now if you go here, you could see your txt file is here. So this information is useful. So this feature is useful for checking the files which are created by your application, or when you want to transfer some files from your desktop to your application and check how does they work. You can see the performance and all. You can even create the folders here, and you can even delete the files here. You have an option deleting. It will delete. And the next one is the examining thread information. So this will show currently how much threads, currently the running threads for the selected process. You can select any process. So I'll select contacts, for example. I'll select contacts. In this, in the device tab, you have an option threads. So if you in the tab, if you see, you can have an option show thread updates. Click on that. You could see all the thread information of that object of the selected process. So here it shows the ID. This ID is a VM assigned unique thread ID. And you can see that the ID, this will be the Linux thread ID. For the main thread in a process, this will match the process ID. And you can see all the status here. The status will be running, sleeping, monitor, wait, VM wait and all. Running is executing application code, and sleeping is calling thread sleep. Monitor is waiting to acquire a monitor log, Native is, you can see the native here, executing the native code. VM wait is waiting for a VM resource. Runnable is running the execution code and all. And if you see here, U time and S time, these are useful for us. This will show, for example, U time. This shows the cumulative time spent executing the user code. It is measured in Jeffys. And S time, this is the cumulative time spent executing the system code. This is also in Jeffys. And the name, coming to the name, this is the name of the thread. So here the status will be differing for different objects. Suppose I select process. I click on here, it will be something else. It will be deferred. Usually it will show the status will be differing based on the process. In the next session, we will be discussing about some more features of DDMS. Thank you.